In this segment, we're going to take a look at quadratic functions. When we graph quadratic functions, which are x squared functions, we always get a parabola. Because it's a function, it's either going to be an upward opening parabola like this one or a downward opening parabola. Two key things to note about these are the vertex and the axis of symmetry. Vertex is really helpful in graphing it, and it's also very important usually in application problems. The axis of symmetry is really important when we're graphing it and making sure that it looks good. The vertex is just simply the turning point. So in this one, it's this lowest spot down here, the point 1, -4. The vertex is an ordered pair. It's a point on the graph. All right. In this one, because it's the lowest spot, it's where my minimum is going to occur. My minimum is going to be -4. If it was a downward opening parabola, it would be where my maximum would be. All right, now this vertical line that I've dashed in here, this is the axis of symmetry. So any vertical line through the vertex of your parabola is your axis of symmetry. And because it's a vertical line, it needs to have an x equals as its equation, and it's x equals whatever that x coordinate of your vertex is going to be. And really, it just helps us say, like if I know one point over here on the parabola, like right about there, then I know the same distance to the other side of the axis of symmetry, I'm going to have another point on the parabola. Two forms for quadratic functions is this expanded multiplied out form and this factored form. Now if I have it in this expanded form, then I know that the leading term is going to tell me if it opens up or down. If it's positive, it opens up, and if it's negative, it's going to open down. Good news is over here in this factored form, we have a number. Sometimes we have a number, but sometimes it's a 1 and it's not written. But whatever this is here in front of the parentheses, that's going to be telling me up and down as well. So if that's positive there, then it opens up. And if I have a negative out front there, that's going to be a downward opening parabola. Now the vertex, if I have the expanded form, it turns out, it's just one little formula I gotta know, that the x coordinate is minus b over 2a, the opposite of b over 2a. How would I find the y value? Well, I would take whatever answer I get from doing this and I would plug it into my function. That's all this notation means. Okay, so you find your x using this little formula and then you plug it in to get the y. The axis of symmetry, remember, is a vertical line, so it's x equals something, and it's x equals whatever we calculated up here for our x. In this factored form, the vertex is hk, and you're like, well, how am I going to know that? Well, we have studied transformations, and we said if something is on the inside of the function, that moves it horizontally, and it moves it opposite to what we would expect. So the minus h actually moves it forward h units, so that's why that's positive h. On the outside, that plus or minus moves things vertically, and it moves it like we would expect, so it moves it up k. That's why it's a positive k. So the opposite of h, the same as k. Axis of symmetry, just like the other one, we would take x equals whatever the x coordinate is of our vertex. So in this one, it's very simple, x equals h.